Hey, geometry. All right, guys, listen up. I am in a battle here, trying to make this Edpuzzle video for week 3, April, because dividing line segments is trying to take me out here. I'm not gonna have it. All right. I'm trying to not only get the answer right, of course I can do that, but I want to make sure that it's not confusing to you. Okay. So dividing line segments. Let's write down some notes that we're going to follow. Number 1, draw a picture if it's not given. All right, write that down. Number 2, determine horizontal, which I will label H, and vertical distances from point to point, that are given. So we have our 2 given endpoints, sometimes we might be given the point in the middle. And then use the correct ratio to multiply those given distances to get desired distances to point in question. See, I'm still. All right, and then add or subtract those distances to get the remaining point. So there's a point we have to get, in this case it's B. Is that right? We want to find out what B is. It's one of those points. So what are the coordinates of B? Aha. All right. So let's figure it out. B is such that AB is 2/5 of AC. So we see the whole thing is AC, and then B has got to be like here. Or it could be here. No, AB. Yeah. So it's got to be, can't be too far because then it wouldn't be 2/5. So, all right. So do we know the distance? No. So we'll call it X, right? But then we know that AB is X, and then, actually we want to call, because why do we not want to call AC X? Because we can figure out AC, right? So we want to determine the horizontal and vertical distances from A to C. So A to C, what's the horizontal distance? So we're starting at -8 and going to 2. So the horizontal distance is 10. What about the vertical distance? We only have to go down 1. So to get from A to C, we go down 1. So let's say 10 to the right and 1 down. Okay, so that is the total distance. So now we want to take, and if we want to start at A, all right. So first, we want to multiply our given distances by the ratio, right? Use the correct ratio. Well, they gave us the ratio in this case, 2/5. So we're going to take that horizontal distance and multiply it by 2/5. So was that 20/5? That's 4. And then 2/5 times 1, that's just 2/5. So our new horizontal distance that we want to move is 4. And our new vertical distance is 2/5. So we want to move 4. Let me use a different color here. So that would be over 1, 2, 3, 4. Oh, so I was off. and then down 2/5. So it's actually right. I was close. So it's 4 and then down 2/5. So that's like 5, and I guess that would be 3/5, remaining fifths. So we're looking for 4 and 5 and 3/5. Let's see if I can find it. -4. Hey, it's the first one. -4. All right. Okay. We're gonna do that one again. Dividing, where's dividing line segments? You guys ready to do this again? Because all of these problems are different, you know? I mean, they're the same, but they set it up different. Like, look at this one. No picture. So what are we gonna do? We're gonna draw a picture. Okay. So A is at 2, -8. I don't know why it doesn't write sometimes. 2, -8. I think I need a new writing tablet. There. And C is at -4, 7. All right, maybe that little part is worn out. So now we're going to draw a line segment. It's good enough. And find the coordinates of B such that on AC such that the ratio of AB to BC is 2 to 1. All right, I like this problem. AB to BC is 2 to 1. So AB is the 2 and BC is the 1. AB is longer than BC. Maybe I'll put it like right here. Maybe it's somewhere like right there. Is that where B is? And what are the coordinates? That's what we want to find out, right? So we're going to go like this. We're going to say this is 2x and this is 1x, 2 to 1, right? And the whole thing would be 3x. We always want the two parts and the whole. And then we're going to identify the correct ratio. But first, what do we need to find? The horizontal and vertical distances, right? From A to C. AC, HV distances. Kind of like when we did dilations. So the horizontal distance, let's go from A to C. So we need to go left from 2 to -4, that's left 6, right? 6 left. And the vertical distance from A to C, we're going up. We're going up from -8 to 7 is 15. 15 up. All right, now we want to start at A, then that is 2 out of 3. These are the whole distances. So we want to make sure we use the whole in our ratio. And then the part is 2. So the ratio is going to be 2/3. All right. If we're starting at A, we're going to B, then we want to use the 2x. And we have our whole distance, which is 3. So our denominator is 3. 2 over 3. Okay, so we're going to multiply our distances by 2/3. And so that's 12 over 3 is 4. 30 over 3 is 10, right? Okay, so these are our new HV distances. Let's call them HV. Okay, so that means if we're starting at A, like I said, to -8, and we want to go left, right? To get from A to B, we got to go left. So let's subtract the 4, and we want to go up. So let's add the 10. Go up and left. So 2 minus 4 is -2. And -8 plus 10 is +2. That must be where B is. It must be at -2, 2. All right. You guys want to do one more? Well, you know what? Why don't you guys try this one for yourself. Follow those steps, and you might have trouble getting the correct ratio, but that's okay. You can post in the organizer. Okay, so find the exact perimeter of this figure. Okay, wow, they're really making us work here. So, and then we got the points inside and outside a circle, and then we got the coordinate plane word problems. All right. Yes, I remember. All right, so this one is in the organizer. And there it is. So with all of these, we're going to use two formulas, the distance formula, the midpoint formula. But the distance formula, I wonder if you remember, is x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. And the midpoint formula is to find the point in the middle of 2 points. You add the x's and then divide by 2. Add the y's and divide by 2. We did this earlier in the year, but it was pretty easy and it didn't take a lot of time. So now you may have forgotten it. So there they are again. But the other thing is, if you want to use the distance formula, fine, or you can use the Pythagorean theorem. Just draw a triangle. I'm actually going to do the Pythagorean theorem in this one because I think it's a little easier. But for the vertical segment, we don't need to do anything but find the vertical distance, right? The x's are the same. So 5 to -1, that's 6. So that's good. And here's a vertical one over here. X's are the same, so 2 to -3, that's 5. Here's a horizontal segment. So 1 to 6, I shouldn't have crossed it, that's 6, that's 5. Here's another horizontal segment. So we're looking at the x's, -6 to 1 is 7. All right, so now we got these two diagonal segments. What we're gonna do is we're gonna draw a little triangle. It's got the 2 and then the 1, 2, 3, 4, 5. 2 and 5. So we can just do a quick little Pythagorean theorem. 2 squared plus 5 squared equals c squared. 4 plus 25, 29 equals c squared. So c is equal to square root of 29. One with me. If not, we have another practice problem right here. Another Pythagorean theorem to find AB. So what's the vertical? 1, 2, 3. Horizontal, 1, 2, 3, 4, 5, 6, 7. Quick little Pythagorean theorem. 7 squared plus 3 squared, 49 plus 9 is 58. So it's the square root of 58 there. All right, so we're looking for, so let's add our whole numbers. 5 and 5 is 10, plus 6 is 16, plus 7 is, what is that? 4, 3, 23. So, and then we don't know what does. So we got the 23 from the whole segments. Then we get the square root of 29. And then we got the square root of 58. Let's see if that's good enough to get us some answers here. Oh, see it right there. I did it. Look at that. All right. It's late. It's 10:42. I gotta go to bed. But let's see about this one. So find the area. All right. So you can do that. So use that distance formula and find the base and the height of that triangle, and have fun. Now, when it comes to the points inside and outside a circle, I do want to do that. Okay. So we're going to draw a circle. And we know the center is 0, 0. That's nice. Center of 0, 0. Where does the point -3, 2 lie? Good question. Oh my. What happened there? Tell you what, this writing tablet is old though. Got this writing tablet in 2008. So hey, it's held up well. All right. So where does this point lie? It all depends on the radius. Okay, so we know the radius is 2 square root of 3. And so if we -3, 2 could be here, could be here, it's somewhere around here. But if I draw, the radius is 2 root 3. So the question is, would this give me a radius of 2 root 3? So if I take, and I'm actually going to do this part, if I go over 3 and up 2, and my circle, it looks like it's inside the circle, but my circle might not be accurate. So let's see just how long this segment is. Okay, so we know that the vertical side is 2. We know that the horizontal side is 3. Let's do a quick little Pythagorean theorem right here. Okay, 9 plus 4, 13, square root of 13. So what is 2 root 3? That is square root of 4 times square root of 3 is square root of 12. So that's the square root of 12. Just figured that out really quickly. But you could also, if you didn't know that you could do it that way, you could just do 2 root 3, and I get about 3.4. And then the square root of 13 is 3.6. And so it appears that the square root of 13 is bigger than the square root of 12, and or the square root of 2 times the square root of 3 is smaller than the square root of 13. So that means that actually my circle is way wrong. The circle that I should draw needs to be smaller, because it looks like that point is outside the circle. So 2 root 3 must be something like that. Let me just show you. Woo, that I'm right. All right, so again, so when we do the Pythagorean theorem with -3, 2, we get the square root of 13, which is 3.6. The radius of 2 root 3 is actually 3.4. Since 3.6 is bigger than 3.4, this is outside of the circle. If they were equal, it would be on the circle. If it was smaller, it would be in the circle. All right, so that's a little bit about that. Okay, and the last question we're going to do in this little puzzle is Felipe, because this is on the organizer. All right, and it's another chance for us to draw a picture. So playing with the triangle and the coordinate plane. The triangle's area is 24, the largest circle he can fit. Okay, so he has a triangle, and he's trying to draw a circle in the triangle. That's what's happening. Something like that. Maybe even a bigger circle. What if I... Look at that. really trying hard here with my pictures. So the triangle's area is 24. Write that down. Area of triangle equals 24. The area of the circle, we don't know, but we need to know it because we need to calculate the percentage that the circle covers of the triangle. So let's find the circle's area and then we'll divide the two areas. How can we find the area of a circle? Well, the formula is pi r squared. So again, we need that radius. We know the center of the circle is at 0, 0. And we know it passes through a point 1.2, 6.1.6. So that means a point on the circle is 1.2, 1.6. So again, we can think of it as we have a horizontal distance. We have a horizontal distance of 1.2 and a vertical distance of 1.6 from the center, which is 0, 0. So we're going to do a quick little Pythagorean theorem because those are horizontal and vertical distances. And our answer will be the radius. So 1.2 squared plus 1.6 squared is 4. It's amazing. So c squared equals 4, which means c equals 2. So the radius is 2. And that means the area for our circle is going to be pi times 2 squared, or 4 pi. 4 pi. So to get the percentage, we're going to take the circle area and divide it by the triangle area. So 4 pi divided by 24 is 0.52. You see that? That's 52%. All right, so there we go. We did dividing line segments. We did area and perimeter. We did points inside and outside a circle, and even a word problem. So is that extensive everything? No. Should probably still have a lot of red questions, but at least that's enough to get us started. So go look back at your organizer posts and see if I answered any of your questions. If so, move them over to yellow. And we'll go over the remaining red questions in class. See you there.